Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your mineralogy teacher, Jen, and it's time for Monday's Mineral. Well, we can't possibly talk about gold and not talk about silver, so here we go. Silver is another noble transition metal that has been known about for thousands of years. Silver in its pure form is a bright metallic silver color. It's opaque, soft, and extremely ductile and malleable. It has a bright white metallic luster, as you can see in this picture. In fact, it is the most reflective metal, which is why early mirrors were made out of this metal, not the glass that we have today, that sort of aluminum mixture, actual silver. Silver is also the most conductive metal in the world. This is because of the single electron in its outer electron shell, which all conductive elements have. Silver's just the best at using this. The only elements that have a higher thermal conductivity, so it's heat, are diamonds, which is a carbon allotrope, and superfluid helium. So as far as metals go, silver is your best thermal conductor and your best electrical conductor. However, we don't use silver a lot because, well, let's face it, we have a lot more carbon. We have a lot more copper for that, and aluminum and things like that, so, less expensive. Silver is a fairly unreactive metal compared to other metals, but it does react to sulfur to create this sort of black tarnish. So it does need to be cleaned regularly. Though, looking at these silver spoons, you can still see that even with the tarnish, that spoon is damn reflective. Anyway, so this tarnish is typically caused by hydrogen sulfide gas, and it forms a black silver sulfide film on the surface. It also reacts in salt water to form silver chloride, so don't wash your spoons in salt water. Don't know why you would. Now, silver is a mineral, just like gold, and just like gold, it has a cubic crystal structure. Specifically, it is a face-centered cubic, as is gold, meaning that it is characterized by having atoms located at its corners and in the center of each face of the cube. This structure is also known as close-packed cubic structure. Silver has a hardness of 2.5 to 3 on the Mohs hardness scale, same as gold. It has a metallic luster, as we've discussed, and it has a silver-white streak. So when you scratch it on a streak plate, that's what it leaves behind. And it has many crystal habits, including massive, disseminated grains, wires, and plates are pretty common. Individual crystals are rare, but can be cubic, dodecahedral, or octahedral. And in case you need to know what that looks like, I am a nerd. So your 20-sided dice is your dodecahedral, and your octahedral is your sort of double pyramid here, your 8-sided dice. Silver has a jagged fracture and a specific gravity between 10 and 11 grams per mole, which is less than gold, but still pretty dense. It also has 2 stable isotopes that are equally common, which is pretty uncommon as far as isotopes go, but there you have it. It's got silver 107 and silver 109, which you can find both regularly. The 2 most common silver ores are argentite, which is this one here, Ag2S, and chlorargyrite, AgCl. So like we said, me and my cat, I don't know who we is, like I said, chlorine and sulfur are the elements that silver reacts to, so of course that's what its minerals are going to be. Silver also readily forms natural alloys with gold, copper, and zinc as well. Silver is another metal that is non-toxic and gets consumed by the general public much the same way that gold does, but be warned, if you consume too much silver, you may become the next member of the Blue Man Group. It's not dangerous, it just turns your skin blue. Well, I hope you enjoyed learning about silver today, and I hope you come back tomorrow for some shocking trivia. I will fossilizate you later.